All right. Let me read this real quick and then I'll zoom in so you guys can see it in the back. It says, identify the transformations of the graph f of x equals x cubed. So that's what I just read. It says that produce the graph of the given function g of x. Then they do this stuff. Okay. So what we're trying to do is the transformation. Now, it's really difficult. I have to teach you the transformation. But again, in the real world, when we use math, we're going to have this, we'll have a transformation to fit real data. So I'm going to map a bunch of real data in the real world, and it'll look kind of like this, or it'll look like over here, or however it looks. And I notice it kind of looks like a cubic. So this right here is my x to the third power. But if it kind of looks like it, then I go, well, then I need to slide it over here and drop it down and stretch it, you know. So it fits the data that I have. Does that make sense? So that's why we need to learn how to transform functions, because Mr. Adams is a math teacher, so I can look at, like, for example, I'm going to do research at Notre Dame this summer. I'm pretty sure it's going to involve some sort of math modeling. And they're going to say, well, you know, we want to make a prediction. What do we do? And I look at the data. I just make a scatter plot. Well, actually, they know. But that's, you know, my job will be to figure out which equation maps the data the best. Okay? Usually the professors have a pretty good idea of how it should look. Sometimes there's stuff that jumps out, though. Anyways, so what I need to do is I need to go back and think about the transformation. So just like all the other transformations we've done this year, there's H and there's K and there's A and there's B, and we have to determine what those values are and how they change the function itself. Okay, so we're going to guess, and based on our guesses, either we'll have a pretty good idea. Now, the textbook teaches you to, like, change these values, -1, -1, 0, 0, and figure out what the new values are based on the transformations. I don't know if we need to do that. But anyways, so let's jump in here. So remember that g of x, whoops, let me write this down for reals, that g of x is going to look like this, where I have a, right, outside the parentheses, times the quantity b, 1 over b, times x, minus h, close that, raised to the third power, plus k. And so I'm going to look at this and try to figure out what's what. Okay? So now if I were to guess, I would say that b is equal to -2. There is no a. I don't have another set of parentheses. I would also guess that h is equal to +3. Remember, the formula calls for a negative sign, so it's the opposite of whatever you see here. And k is equal to 0. Now, what does this mean? Well, this b does the compression vertically, right? Or it stretches it. It depends on the value. Since this is greater than 1, well, let me be careful how I word it. It's less. It's not a fraction. Okay, it's an integer, -2. This is going to do compression or expansion. So we're going to circle back to that in a second. But I know that h, because h is positive, that's going to shift it what? Well, somebody tell me what the h is going to do. Well, it's left or right, but based on the value being +3, what does that mean? Yeah. So that means we're going to go to the right. How many units? 3 units. Good. So this means that I'm going to go to the right 3 units. What does k do? It does the up or down. Yeah, and the value is 0, so we're going to go up or down 0 units, right? So just put up or down, and then we're going to say 0 units. Does that make sense? Good so far. Now this B, does anybody remember what B is? It's the vertical compression, right? Or not vertical, horizontal compression or expansion. And I was trying to figure out a way to say it. No, that's not left or right. It's gonna horizontally compress it or expand it. And I'm gonna let you in on a clue. We had a fraction on the previous problem and it compressed it. So that's my clue to you. We don't have a fraction now, so what do you think that means? Yeah, so that's yes. So this is an interesting thing, and the publisher of the textbook is really kind of funny. So there's two ways to look at this. If I think of it as horizontal, that's not how you spell horizontal. Horizon. It would expand it. Okay? But now, if you think of it as vertical, and there's a reason I'm telling you both, if you think of it as vertical, what does that mean? Well, vertically, it would do what? Compress, yes. And I don't know how I feel about that. It's probably very confusing, but so let me explain what that means, right? So if I take something vertically and I compress it this way, what it kind of does is it expands it horizontally, right? Technically, the A is supposed to do the shifting around. And there's two ways to look at it. I could label this as a B, or I could label this as the A. In other words, I could say that B. I could say that B is equal to -2, or I could say that A is equal to -1/2. And that's also another little issue that I have. So if it was B, we would say horizontal expansion. If it was A, then I would say vertical compression. I mean, you guys are going to graph it anyways on a graphing calculator, but it is kind of nice to know that you could do both. And so that's part of the challenge with this, is trying to figure out what it is that they're trying to say, because it's ambiguous as to whether or not it's A or B, right? If it was B, it would be inside the parentheses. In other words, if I could push this through, but because it's outside of the parentheses, in other words, I don't have this, right? So I wrote down B, and I got to think that through. I think mathematically this is wrong. So scribble that out. And I think the reason for that, the justification for that, is because this is not in parentheses. So if I look at this, Mr. Adams kind of made a mistake there. If I look at this, we would raise b to the third power. And since this is not in parentheses and not being raised to the third power, then it's an a term. Okay, so Mr. Adams made a slight mistake there. Okay, did I confuse you guys by making that mistake? Okay. It's okay to make mistakes as long as you fix them. See how I caught it before I did it? All right. So now that we know that it is a vertical compression of negative 1/2, what do you guys remember when A is negative, what that does? It does something else too. It flips it, right? We would, a formal way to say it would be reflects about the x-axis. The word reflects looks weird. Reflects across the x-axis. We're going to flip it upside down. Okay. So now what I want to do is I'm going to graph. Let's do this in Desmos real quick. Okay. So in Desmos, can I clear everything? Let's try it. Yeah. So I'm going to say y equals x cubed. All right, that's our parent function. And then I'm going to say y equals, and I'm going to put a parentheses, and then I'm going to put 1 over b, and then I'm going to put a second set of parentheses. Then I'm going to put x minus h, and I'm going to put a slider for h, and then I'm going to raise that to the third power plus k. No, just kind of watch and pay attention. You could sketch this if you want to. Now, the parent function occurs when k equals 0, h equals 0, and a and b are equal to 1. So notice that my blue line is right on top of the red line. So what we're going to do is we're going to do some transformations. Okay? What was my h value? 3. Watch the blue line as I move this slider from h. I'm going to change that from 0 to 3. What is the graph doing? It shifts to the right. Now, when I change that to 3, it shifts it 3 units to the right. Okay? Our k value is 0, so it's not going to go up or down, but I'm going to shift it to kind of, do you see how it does that? When k is positive or negative, it's just shifting it up or down. Now, b is going to stay 1. I made a mistake earlier, but b is 1. But what did we say that a was? Negative 1/2. So watch what happens. As soon as I go to the left, well, let me explain this first. When I have, as soon as I make it a fraction, see how that compresses it vertically? So from 0 to 1, it compresses it vertically. When a is 0, it'll disappear. But now, what happens as soon as a is negative? Let me show you again. Positive, it flips it, right? And we need it to be at a negative 1/2 or negative 0.5. Now, negative 1 flips it completely. There's no compression or expansion. Notice that the blue line looks very similar to the red curve. But when it's between 0 and negative 1, in other words, it's a fraction of some sort, it vertically compresses it. Now, if it's greater than negative 1, it vertically stretches it. Does that make sense? But our value is negative 1/2 or negative 0.5. Okay? And that's it. So I'm going to take a screenshot of that. Now, what they want us to do what they're asking us to do, and I just don't feel like doing it because I do what I want, is they're asking us to determine what this graph would look like. Well, it looks like it crosses at about right here, right? It looks like it crosses about 1.5, 2. In fact, let me just look it up exactly, and I can find out exactly where it crosses. Yeah, 1.3, 2.3. So if I go over 1.3 and go up 2.3, it's going to cross right about here. This crosses at 3 over here, and then it goes off the thing. So it looks like it comes down through here. Actually, so it kind of looks like that. And that's all I want. Well, what did it do? Well, we shifted 3 units to the right. And we shifted up or down 0 units. And then you could see that it's a vertical compression, right? That's what we said, vertical compression. And also that it flips across the x-axis. Are there any questions on that? So if I see data that looks like this, then I go, oh, well, I'll just flip it. I'll just do it. And then I know A needs to be negative. If I need to expand it, I know. And so we're actually, remember the marble slide thing? We're going to do marble slides for this at some point in time. Does anybody have any questions? No? I'll leave that.